Today on Q&A Mondays, we talk about design pressures and how to meet certain wind speeds with your metal roofing system. What's up, guys? Welcome to another Q&A Mondays here on the Metal Roofing channel. Got Jeff Hawk back on the show today. We're talking about design pressures. And in a past Q&A, we talked about how UL 90 doesn't necessarily mean 90 miles an hour, right? That doesn't correlate one-to-one. So today we're going to talk similar in that vein about design pressures and how to meet a certain wind speed based on your system. So first of all, can you tell me a little bit about the steps in figuring out wind speed and design pressure?
Well, we get a lot of calls about, contractors calling up saying, hey, I need to meet a certain design pressure, say I need to meet a certain wind speed, say 130 miles an hour for this specification. And they ask, can we meet it? Well, the steps you have to do in order to actually get the engineering for that, you might have to go and get ASCE 7 calculations done. You might have to get a third-party engineer involved. But before you do that, we have a chart that enables you to get a good idea of whether or not your system is going to be able to meet that before you go out and you spend money on third-party services to get that job-specific engineering.
Sure. So can we take a look at that chart?
Yeah. I guess the first thing you need to figure out is, what system you want to use, what the decking is, and then correlate that to the design pressures that we have for engineering on that system.
Okay.
So, if you have a tech stick or if you go online, you can see an engineering cheat sheet or pull up a test report, and you'll see the design pressures we got for those systems. Over here, we'll use, for example, the very first one, 1.5 inch mechanical over plywood. It got a design pressure of a negative 106.75. So that's the first step in determining, whether or not your system's going to meet a certain wind speed, is knowing the design pressure that you have to work with. The second step is, determining the exposure category for the building, because these are all things you're going to need to know to use the chart when it comes to the FPC, the chart we have on our FPC approval.
Okay. Can you tell me what design pressure means, first of all, just as in general?
Okay. So when you do a uplift test, whether it's a UL 580 uplift test, 1897 uplift test, those are both over solid substrates, or a ASTM E1592 test for over open framing, you get two numbers at the completion of your test. You have a test pressure and a design pressure. Your test pressure is what pressure it ultimately achieved. So say the test pressure is 200. Your design pressure is that pressure minus 50%. So your test pressure would be 200, your design pressure would be 100. To put things in perspective, a UL 90 rating needs at least a 52.5 design pressure in order to achieve UL 90.
Okay.
And these are all in negatives. So it's, negative 200, negative 52.5.
So what are exposure categories? Is that the next logical step here?
Yeah, exposure categories are going to be exposure B, exposure C, exposure D. Exposure B is going to be suburban and urban areas, areas that have a lot of crowded structures, not a lot of open terrain. So cities, industrial complexes with a lot of buildings around it, a lot of obstructions, for lack of better words. Exposure C is going to be more open territory with fewer obstructions. So, you have a house out in a field, things like that, where there's not anything to really block the wind that's coming through the terrain. And then exposure D is classified as, any flat area with access to wind flowing over open water. So those are going to be, obviously more marine environments where you have that wind able to pick up speed with no obstructions over the water and, get to the ground surface area.
So we have design pressures, we have exposure categories. What's next when we're considering design, location, stuff like that?
Okay, so we talked about, the design pressure and the panel you're going to use, the category that it's going to fall under. Things come into play as far as your roof mean height. So, the average height of your roof. Whether your building is partially enclosed or fully enclosed, because that affects how the wind's going to affect your project. And then slope plays a factor. The chart that we have covers slopes from a 212 to a 612. So these are all things to take into consideration. Another thing is the different zones of your roof and the different pressures you might have to meet for each zone. you might meet, say, 130 mile an hour with your design pressure in the field, but not in the corners. So these are all things to take into consideration when you're starting the process of determining whether or not you have a chance of meeting a certain wind speed.
So let's talk about zones of the roof. Tell me a little bit about those.
Okay, so your standard zones are 1, 2, and 3. The one is going to be your field area of your roof. 2 is going to be the perimeter, and 3 is going to be your corner zone. They do have 4 and 5, and that's corner zones with overhangs and things like that. Okay. But for our talk, we'll just stick with 1, 2, and 3 and make it easy.
And we can see a couple examples of that here.
Right, and the zones are going to play out depend on the shape of your roof. You have a zone 3 on your gable roof where the ridge is and the 2 gables meet. Over here with your hip roof, where the ridge comes up, it's only of zone 2. So it's all the different pressures that you're going to have to meet for the areas. And depending on what kind of testing you have, it might determine your clip spacing or whether you can do the job at all.
Okay. All right, so what are we looking at here?
Okay, so this is the chart on our FPC approval, Florida product approval. It was done by a third-party engineer, professional engineer. And this gives us an idea of how our design pressures can correlate into wind speeds when we're looking at different projects and before you go out and, again, you spend money on a third-party engineer to do project-specific calculations. So, like we talked about before, the design pressure that we used in an example was a 106.75 for the 1.5-inch mechanical over plywood. This chart, as it says right on it, is good for gable and hip roofs in exposure B for roof slopes between 212s and 612s. So if we look at the chart, it'll give us 2 options for building type, enclosed and partially enclosed. So we're using 130 miles an hour as an example for wind speed. So say it's in exposure B, we got a hip or gable roof, and we're talking about an enclosed building. We can say we have a 30-foot roof mean height to use as an example as well, because you have different charts. There are different options as far as roof mean height. So again, zones 1, 2, and 3, field, perimeter, and corner. Zone 1, according to this chart, we need a negative 16.7 at a 30 roof mean height. So we more than exceed the design pressure there in zone 1. Zone 3 is going to be your highest pressure needed. So let's go look at zone 3. If you can meet it in zone 3, you can pretty much meet it anywhere on the different zones with your design pressure. So zone 3 at a 30-foot mean height at 130 mile an hour wind speed, you need a negative 42.9. So again, if that's the case, you can feel pretty comfortable knowing that your design pressures are going to meet it.
Yep.
So that's exposure B. That's the area that's really crowded and has a lot of obstruction, so a lot of wind can't get there. So let's look at the worst case scenario, and that's exposure D. All right, so exposure D, again, worst case scenario. These are the highest design pressures, for this concerning the different exposure categories. These are where you're going to need to meet the most. We'll do the same example. 30-foot mean height, enclosed building, 130 miles an hour. Zone 1, as in comparison, 30-foot mean height, that you need a negative 27.6. But when you get down to your corner pressures at a 30-foot mean height, you need a negative 71.2. Because your corner is what is going to take all of that wind pressure. That's going to be the most vulnerable area on your roof. Again, you can see that we meet it with the negative 106.75 design pressure, but depending on your exposure category and where your project's located, 130 miles an hour in exposure D doesn't necessarily mean the same thing as 130 miles an hour in exposure B.
Right.
And that's where a lot of the confusion comes in. It's not as simple as can my roof meet 130 miles an hour. There's a lot of factors that play into it.
So do you always need a chart to reference this, or do you always need a third party to test it out?
You don't always need it. Sometimes the architect will actually list a design pressure because they've done the calculations and they know what they want. They understand that design pressures correlate to wind speeds and things like that. If that's the case and they list the design pressure, then you can just go straight to the engineering cheat sheet and determine what design pressure they're looking for. It'll give you the different zones. They do that as well, and find a system based on the engineering that you can offer and that can meet those pressures that they're asking for.
Okay, well, let's look at another practical example here. So let's say I have to meet a certain wind speed. How do I go about making my selection when it comes to a system?
Well, you can do the process in reverse as well. You can go to the chart first to get an idea of the pressures that you're going to need to meet for the different zones, and then go to the engineering cheat sheet the test reports and determine whether or not those systems meet those design pressures. Because they do fluctuate between different panel systems, different deck assemblies, different materials,
right.
Things like that. So you can do the process depending on, if you offer 6 different options, it might be faster to go through and figure out what you need on the FBC chart first, then determine that with the panel options you have. If you offer one panel, then, it doesn't really matter which way you go.
Yep. So if someone wants to find this chart or some other information that we have, where can they look for that?
Okay, so we have this listed on our website. It's not everywhere since it is an FBC approval or Florida product approval. We have it attached with our Florida product approved systems.
Okay.
So that would be the 1.5" mechanical, the 1.5" snap lock 550, the 1.5" or the 1.75" snap lock, and the 2" mechanical panel. It'll be in there referenced on the left-hand side under Florida product approval. And if you open that up, you scroll down, and towards the end of the PDF itself, the chart will be there.
Okay.
It's just a good reference point, for contractors wondering, people wondering about, what's kind of wind speeds their systems could take. It's a good piece of information to have, and we use it quite often when dealing with contractors wondering about, whether or not their system can meet the needs of the specified design.
Well, thanks, Jeff. If you guys want to check out this information, you can visit the Sheffield Metals website right here. Comment below if you have any questions. Subscribe to the Metal Roofing channel, and we'll catch you next time.